Hello everyone, this is Ketish here. In this video, I'm going to go through the Combined Science Foundation tier from AQA, Physics Paper 2 from 2021. Question number 6 is on the topic of forces. Figure 8 shows a stretched spring. The spring is elastically deformed. What does elastically deformed? That means it's actually extended, and if you remove the force, which is the hanging masses, it will go back to the original shape. That's what you call elastically deformed. If it doesn't go back to its original shape, we call it inelastically deformed. So what is meant by elastically deformed? As the force on the spring increases, the length of the spring increases. No, only a small force is needed to stretch the spring. No, the force on the spring causes it to change shape. No, the spring will return to its original length when the force is removed. That is correct. Describe a method to determine the extension of the spring. Now, how do you find the extension of the spring? So without the mass, let's say the spring is only up to there, that would be the original length. You'd use a ruler to measure the original length. And then with the masses, you would use the ruler again to measure the extended length, and you take away one from the other, and this bit is the extension. So how do we write that answer? Use a ruler. Use a ruler to measure the original length of spring without a force, right? Then measure the new length with the force. Spring extension equals new length, which is going to be bigger, minus the original length. This would give you 1 mark, and this equation would give you the second mark. The extension of the spring is 80 millimeters. The spring constant is 40 Newton per meter. Calculate the elastic potential energy of the spring. Now, elastic potential energy of the spring, use the physics equation sheet. This is the equation that you would find. Elastic potential energy is EE equals half KE squared. So half is 0.5, 1 over 2 is 0.5. K is the spring constant, which is 40 here. And the extension is 80 millimeters. Now, you can't use it as 80. It has to be in meters. To convert 80 millimeters to meters, you would divide it by 100. And that will give you 0.8 meters. Now, 0.8 meters squared. So you get 1 mark here. Students often fail to do that conversion and lose a mark. And the second mistake that they would do is forget to square this 0.8. And they would lose another mark, and finally losing all the marks. So let's bring up the calculator. Let's do 0.8 squared first. 0.8 squared equals 0.64 multiplied by 0.5 times 40. That gives me 12.8. Somewhere I have made a mistake. Yes, the mistake is this. Converting 80 millimeters to meters, I should be dividing it by 1,000 because there's 1,000 millimeters in a meter. So that would give me 0.08 meters. Let me change this value over here. 0.08 squared. So let's try that again. Square root of 0.08 equals, leave that as a fraction, multiply that by 0.5 times 40. That gives me 0.128 joules. 0.128 joules. Write down the equation which links extension, force, and spring constant. Again, you can use the equation sheet for this. So the equation that links all three is force equals extension times spring constant. Or you could write it in the form of symbols as well. F equals EK. Question 6.5. A force of 300 Newton acts on a different spring. The force causes the spring to extend by 0.4 meters. Calculate the spring constant. So F equals EK or KE, doesn't matter whichever way you write it. So the force is 300 equals the extension is 0.40 times the spring constant, which is K. So in order to get rid of 0.4 from this side, I would divide both sides by 0.4. So 300 divided by 0.40 equals K, which is equal to, let's bring up the calculator again, 300 divided by 0.0, no, 0.40, and that's 750 Newton per meter. 750 Newton per meter. That brings us to the end of question number 6, and I will see you in question number 7.